Hi, Professor Blanco. My name is Celena Adipietro, and the last four digits of my student ID number are 9773. This is Contemporary Theories of the Solar System Recitation class, section 28898, and this is my video for study guide 17. Okay, on my honor, I attest that I will follow the letter and spirit of all of this assignment's rules. Then I signed it and dated it. For the first part, add 2024 to the last three digits of your student ID number. I got 2,797. Add up the digits of W, I got 25. Divide W by 100 without rounding off your answer, I got 27.97. Then for the first question, from three different reference sources, get a reliable estimate of the number of nuclear warheads, atomic bombs, that currently exist in the world. Calculate the average of the results from these three sources and multiply that number by the energy of the atomic bomb that was detonated over Hiroshima in August 1945. That is your estimate of the amount of energy in atomic bombs that currently exist. How many joules is this? Give your answer to exactly two significant figures and remember to cite your sources exactly. So according to Stockholm International Peace Research Institute 2023 report, estimated nuclear warhead count is 12,500. Federation of American Scientists 2023 estimates 13,000 nuclear warheads worldwide. Bulletin of Atomic Scientists in 2023 estimates 12,700 warheads in 2023. So adding up these three values, I got 38,200, and you divide that by 3 to get the average, so 12,733 would be the average. And then the amount of energy looking up in a Hiroshima atomic bomb is this value over here. So I have to multiply them together over here to get the answer. And when we round it to two significant figures, I got 8.0 times 10 to the 18 joules. For 2, before doing any calculations, write down a guess. What everyday object would produce that many joules of energy if, following the equation E equals mc squared, you converted that object's mass to energy? Here are some possible example objects: a sheet of paper, a pencil, a cell phone, a laptop, a refrigerator, or a car. Explain very briefly why you feel your guess might be correct. Okay, so first I wrote the formula E equals mc squared, and then you have to rearrange it for m equals e over c squared. Then taking this value from the question above that it's talking about, and dividing that value is e, the amount of energy, and c is given, so it's 3 right here, 3 times 10 to the 8th meters per second squared. And when you divide those, you get 88.9 kilograms, which equals 196 pounds. So a sheet of paper is not 196 pounds, a pencil is not, a cell phone is not, a laptop is not, a refrigerator could be, and a car definitely is not, so I guessed a refrigerator. So using E equals mc squared, we converted 8 times 10 to the 18th joules to 88.9 kilograms of mass. This equals 196 pounds, which is equal to a refrigerator. Okay, 3. Now using the equation E equals mc squared, calculate the total amount of mass that would be converted into energy if all of these nuclear warheads were detonated all at once. Give your answer in kilograms to exactly two significant figures. Okay, so the average mass of a nuclear warhead is 500 kilograms, and there's an average of 12,733 in the world, which we figured out in the previous question. So when you multiply those together, you get 6,366,500 kilograms. I also used the equation over here, E equals mc squared, but then when I reread the question, it looks like it's just asking for the amount of kilograms. Let me just double check that. I'm actually just going to change my answer very quick, or keep two answers, because I'm not too sure. No, I'm just going to stick with the first one. So I think it was asking this right here, and rounded to two significant figures would be 6.4 times 10 to the 6 kilograms. So that's what I got for that question. Now look up from 3 different reference sources. Get a reliable estimate of the mass in kilograms of the household objects you mentioned in question 2 above. Calculate the average from the results from these 3 sources. Was your guess close to correct? So from Consumer Reports, a refrigerator would be 90 kilograms. From Whirlpool, it would be 80 kilograms to 100 kilograms. And from How Stuff Works, it would be 100 kilograms. So the average of 90, 100, and 100 is 290 divided by 3 to get the average, 96.67 kilograms. And I answered yes, 88 kilograms is close to 96 kilograms. The sun, for number 5, the sun converts more than 4 billion kilograms of matter into energy each second. Write a short paragraph between 20 and 40 words long about what you feel about how the amount of energy humanity can generate with all of its weapons compared to the power of the sun. So I said, comparing 6,366,000 and 4 billion, the power of the sun is significantly larger than the amount of energy humanity can generate with all of its weapons. Okay, so that would be the work for study guide 17, and something I learned with this study guide was about how the energy of all the atomic bombs in the world is not even close to the amount of energy in the sun. So that's definitely interesting and something I will always remember. Okay. Thank you.